Hello there. I would like to talk to you about a common element of physics education today, online homework. In most online homework systems, students are presented with very basic conceptual questions. These are a good measure of reading comprehension or of simplified calculations. As they face more rigorous problems, however, some students excel, while others struggle, get partial credit, and then move on. Struggling students haven't truly mastered basic physics concepts and mathematical techniques. End-of-chapter problems in textbooks have been added somewhat randomly over the years to match and complement section narrative, but are not reliable indicators of student comprehension. Online homework assignments do not reinforce basic problem-solving techniques. Neither instructors nor students have in-depth diagnostics before an exam to demonstrate student preparedness and strengths or weaknesses. In addition, there aren't enough options to practice before an exam. Struggling students enter unprepared, lacking even basic problem-solving techniques, and suffer the almost inevitable consequences. To address the needs of the struggling student, we have created the Physics Extreme Training Engine, or PEAT. PEAT leverages a student's own intelligence to create breakthroughs in understanding physics. Students will increase their conceptual and quantitative understanding of basic physics principles through a game-like approach. It looks like we've already mastered the first two modules of this section, so let's open up the module for Newton's laws. PEAT builds a student's confidence in his or her problem-solving skills by starting with the easiest applications of the concepts and building up to more complex and related problems. In this example, we are already on the third level of this module as indicated by the progress bar and by the colored dots in the upper right. Having successfully answered this problem, we are presented with a clear formal solution representative of the concept being developed, and because we have previously been successful on this level, we are rewarded with another green dot and move on to level 4. If a student desires, they can request a hint, which gives a short piece of advice related to the nature of the problem on the level. Even with the hint, our answer to this problem was incorrect. The solution is provided so that we can see where we went wrong in our attempt, and we are prompted to move on to the next question. Each level is populated by a randomly generated series of scenarios and dependent variables in what we call a question suite. Students will repeat a given problem type in different contexts until he or she has achieved proficiency. At any point, a student can request to see the solution to the previous problem in order to leverage that knowledge on the current exercise. Noting that having gotten one problem on this level incorrect, we need to answer a few correctly in order to demonstrate we have truly mastered the objective. Each level focuses on only one new idea or technique, and that narrow focus creates a comprehensive learning experience for problem solving. For our demonstration, we will fill in the remaining dots and see that we have mastered the module and are now prompted to move on to focus on another discrete concept. Through this scaffolding approach, a student who might otherwise struggle can build their own conceptual and mathematical support at their own pace and on their own terms. PEAT, a new way of approaching online physics education.